Hi, everybody. It's Miss Austin, and I'm going to be going over the Unit 3 Lesson 11 problems, which start on page 81. So today we continued our learning about imaginary numbers. We looked at the plotting imaginary numbers and real numbers. And then we put imaginary numbers and real numbers together, complex numbers, in the complex number plane. And so this first question says, which point represents the complex number -3 plus 2i? Well, so this is my real part. So I'm going to go -3, and then that's my imaginary part. This is my imaginary. So I go -3 in the real direction, and then +2i in the imaginary direction. That would land me at point A, which is A. Match each expression to an equivalent expression. So there's a few things that I want to kind of write down as a guide, and you might need to write these down for a while, right? The square root of -1 is defined as I. And then that means if you look at that, if we square that, right, that means I squared is -1. Okay, so this one is one you're probably going to want to really get comfortable with, and then this idea as well. Okay. So let's look at these. Now let's go do our operation. So this first one, so I've got, and you sort of just treat I as a variable, and then at the end sort of assess its value based on one of these over here. So we've got 2 times 8, 16i. And I alone, is the square root of -1, which that's not a choice over here, but 16i is, right? So we've got this one is number 4. 16i to the third. Well, if we use our power properties, we're going to break this down a little bit. I to the third is I squared and then one more I. Now, why would I want to say that? Because I squared, right? And I wrote that over here. I squared is actually equal to -1. Look at that. So that means this is really 16 times -1, which would make -16. And then I've got the I after it, which can't be broken down any further. So the letter B is -16i. This one right here. These arrows are going to get confusing. I'm going to go like this. All right, letter C, 2i to the fourth. Well, each of those needs to be raised to the fourth power. So we've got 2 to the fourth, and I'll go over here. So you're going to raise 2 to the fourth power and I to the fourth power. So you're going to end up with 2 times 2 times 2 times 2 is 16 I to the fourth. Now you see over here, that's not a choice. We need to break down this I to the fourth. So my thinking is that is 16 and an I squared and another I squared. I squared and I squared makes I to the fourth. Why would I want to do that? Because I squared can be replaced with -1. Those are both just -1s. So anytime you can break it down to an I squared, that's helpful because I squared is equal to -1. So this is actually 16 times a -1 times another -1. So this is what? 16 times -1 is -16 times another -1 is +16. Totally taking up all the space here. And I mean, the last one that leaves us for is number 1, but let's make sure it makes sense and that we get what that says. So it'd be 2 times 8 is 16. I times I is I squared. But what is I squared? I squared is -1. So that's 16 times -1, which is -16, which, yes, is number 1. I'm going to do a big loop-de-loop right there. Okay. So having this written on your paper and just getting comfortable with any time you can, if you see I squared, you can replace that with a -1. And so if you have higher powers of I, you can break them down using our exponent properties that we did earlier in Unit 2. All right, number 3. Diego squared a number and got 4. Andre squared a different number and got 4. What were the numbers that Diego and Andre squared? So, I mean, if you need to think about it visually, it's like, what number squared can give me 4? The number 2. 2 squared is 4. So there's one number. And then what other number squared could also give me a positive 4? A -2. So in our lesson today, we learned if you're looking for what number squared can give you a positive integer, there's a positive answer and there's a negative answer that can create this number right here. Okay? Then it says Jada squared a number and got -4. Now, up until lesson 10, we've been telling you, oh, sorry, x squared can equal a negative. Now we've been introduced to imaginary numbers. So what number squared can be -4? And then it says Elena found a different one. Okay, so think about this. What number times itself can make that or go backwards, right? What's the square root of 4? 2. And that's times the square root of -1, which is just I. 2I squared. 2 squared is 4. I squared is -1. That would make -4. And then same thing, okay, every negative number also has 2 solutions, the positive and the negative. Let's just make sure that makes sense to everybody. -2 times a -2 makes 4, because a negative times a negative. And then I times I is I squared, but I squared is -1. And 4 times -1 is -4. So the big idea here is if you're looking for the 2 answers of what x squared can equal, if you've got a positive number, right? You've got the +2 and the -2. If you're looking for what 2 numbers can square to make a negative number, it's going to be +2i or whatever that number is and -2i. If that was a -9, it'd be 3i, -3i. All right, find all solutions to each equation. So now we're going to kind of apply what we just talked about. So what number squared can equal 1? Well, we just said there's 2 numbers, right, that can square to make a positive number. I've got 1 and I've got -1. 1 times 1 is 1. -1 times -1 is 1. Okay, how about 13? That's positive still. So I've got, this time that one came out to a nice whole number, right? Here, the square root of 13 doesn't have a non-terminating decimal. So square root of 13 and negative square root of 13. Whoopsie daisy. Miss Austin almost wrote a negative. Okay, now what about this one? How can a number squared equal a negative? Because now we've got these, right? So you could think of it this way. You could break it apart like this. What's that? 3. What's that? I. And then there's also -3i. Last one, d squared equals -5. As soon as you see that negative, you know it's got to be an imaginary solution, right? So we've got, now this time, 9 has a square root, it's 3. And then the square root of -1 is where I get the I. This one, I can write it like this. That doesn't have a square root, so it's going to have to, or a non-terminating square root, so I'm going to have to leave that like that, but I can still write that as an I. So my answers are I positive square root of 5 and negative I square root of 5. Those are my two answers. All right, number 5. This is a review question. Find the exact solution or solutions to each of these equations, or explain why there is no solution. So before I even get started, I just want to address, because we just took the quiz and some people are like still confused. These are all cube roots. Look, cube root, cube root, cube root. Cube roots always have one answer. None of these are going to have a no solution. Cube roots look like this. Cube roots can equal positives. Cube roots can equal negatives. All of these have answers. You could do these mentally, or you can do the steps to get the variable alone. I'll do the steps. I'm going to cube this side. I'm going to cube this side. I get a plus 2 equals 4 times 4 times 4 is 64. Subtract 2, 62. Plug it in and check it. Okay, here. Now, because the 5 is not under here, I'm going to move that first before I cube both sides. Cube root of b equals -1. Some students are like, oh, no solution, it's a negative. No, cube roots can equal negatives. So cube, cube, b equals -1. And last one. Again, this 14 is not under there, so I'm going to move that first before I solve it. And by the way, you could solve these mentally. It's fine. Like right now, what number has a cube root of 10? 1,000. So what number do I need to put there to make this 1,000? 1,001. Okay, if that's too much, let's do the steps. Cube, cube. C minus 1 equals 10 times 10 times 10 is 1,000. Add 1 to both sides. C equals 1,001. Last one. Explain how you know that the square root of -1 is not a negative. So one idea would be properties. When you multiply, if you multiply a negative number times a negative number, you end up with a positive. Okay, that's a property of negative numbers. Watch this one. If I do negative square root of 1 times negative square root of 1, the answer is -1. That doesn't follow what is true about negative numbers. A negative times a negative should result in a positive. This does not. Doesn't result in a positive. Okay, I hope that was helpful. I will see you soon.